Hi, we're Elm Engineering Solutions, presenting our project on the rehabilitation of a section of Larimer County Canal. Our team was hired by Water Supply and Storage Company, the owner of the Larimer County Canal. Water Supply and Storage Company, or WSSC, has multiple facilities across Colorado, with the Larimer County Canal spanning 58 miles and delivering irrigation water to approximately 40,000 acres in Larimer and Weld counties. The section of canal to be rehabilitated is located approximately 5 miles north of Fort Collins, Colorado, at the intersection of East Douglas Road and North County Road 13. Due to changes in land ownership, buildings have started to encroach on WSSC easements, and access to the canal has been restricted over time. With water supplies being so important to the counties, upkeep of the canal is one of WSSC's priorities. Water has been eroding the banks and affecting the homes along this particular section of canal. Overgrowth of invasive species has led to accessibility difficulties to this section of the canal, which has made maintenance and rehabilitation very difficult. The canal in this area has eroded so much that it is encroaching on some of the homes along the bank. The access concerns for maintenance and upkeep and the erosion concerns impacting canal integrity were projected to continue to worsen. The purpose of this project is to mitigate the significant erosion affecting the canal section and to increase access to the canal itself. When working with Water Supply and Storage Company, we looked at two potential design options: box culverts and articulated concrete blocks. We were directed by the client to evaluate first and foremost the box culverts to line the entirety of the canal section. We quickly realized that the articulated concrete blocks were a more practical and cost-effective solution. In order to do our due diligence, we designed for both options. Shown here is the box culvert design requested by our client. As you can see here, to cover the whole bottom width of the canal, two 12 by 10 foot box culverts are placed side by side. The longest stretch of the canal is 913 feet long, and the two smaller sections are 119 feet and 123 feet respectively. This makes up a total length of 1,155 feet of box culverts. On the inlet end of the box culvert, we designed wing walls, seen here. The main purpose of the wing wall is to prevent erosion and damage to the box culverts from the force of water flowing in the canal. Additionally, we hope this can help prevent settlement and future structural damage. After the box culvert design was completed, articulated concrete blocks were designed as a more practical solution. As seen here, ACBs will be placed along the banks and bottom of the canal. Closed cell blocks from ShoreTech were chosen as they had a high factor of safety. The blocks chosen are SD475CC, which is a flexible interlocking matrix of concrete blocks of uniform size, shape, and weight connected by a series of cables which pass longitudinally through pre-formed ducts in each block. These blocks combine favorable aspects of lightweight blankets and meshes such as porosity, flexibility, vegetation encouragement, and habitat enhancement with non-erodible self-weight and high tractive force resistance of a rigid lining. To address these goals, box culverts were designed and will be installed along this span of canal and under the bridge that denotes the downstream end of the canal. This design mitigates erosion due to the canal being lined with concrete and provides WSSC the means to drive over the canal to better access for maintenance of the sections lined by private property. As civil and environmental engineers, we strive to engineer solutions to issues that are sustainable, practical, and beneficial to our clients and the general public. Thank you for viewing our project video. Have a nice day.